There are a lot of different database engines which we can take a look at. We're going to look at one of the simpler ones, which is basically just a file system database. Something called SqliteLite, which is incredibly light, incredibly easy to use. Now, you're going to be working with a database that's more complicated than what we have here. But I wanted to go through a couple of different things for you and also bring it back to Express a little bit too. So what I'm going to do here is that if I was to go in, notice that I have nothing in this folder. And I'm going to go in here and I'm going to say SQLite 3, because I have SQLite installed. And I'm going to specify SQLite 3, and I'm just going to give it the name of a file. I'm going to say Acme DB SQLite. Doesn't really matter what the extension is. And I'm going to hit enter. Okay? What I ended up doing at this point is I ended up creating a database. It's an empty database. How do I know? Well, there's a couple of commands. And again, all database engines have a little bit of a different syntax. I don't want you to go nuts with SQLite because this might be the only time you'll end up using it. But if I was to go and look at schema, which describes the database, it's empty. There's nothing there. If I wanted to leave my SQLite environment, I could do quit, and I've exited my SQLite environment. If I say ls.alt, I'll see that I actually have a database that's there. Just by naming the database, it gets created. So for instance, if I say SQLite 3 foo.sqlite quit ls.alt, I'll see, I lied to you, SQLite 3. I bet what's happening here is if I do that foo SQLite 3 foo SQLite, okay? I think once I end up doing anything with it, even something like schema, I'll end up seeing that it's there, okay? Now, if we wanted to work with our database, one of the things we could do is we could say SQLite 3, and if I just hit the tab, it'll finish this for me. And what I could do, what's a database really made up of? Well, when you think about a database, is a database, or what I should say is a relational database, is made up of tables. And those tables define the different relations. So for instance, let's just think about the Acme Corporation. Let's say that the Acme Corporation has users, and let's say that the Acme Corporation has departments. Okay? In which case, one of the things I could do is I could create a table, okay? And I could call that table users. And you don't have to necessarily memorize this syntax. This is not something that you're going to have to do on a regular basis. Just realize that there is a syntax for creating tables and modifying tables, basically a syntax for creating the schema of your database. So I'm going to create this table users, okay? And I'm going to specify that I have a name column, because users should have a name, of text, okay? I could have an email column, I could have a first name column, last name column, I could have a date of birth column, but again, I'm keeping this rather simplistic. Once I end up doing that, and I go and I look at the schema this time, it'll basically just give me the command that I used to create that table, okay? Now right now, if I did a select, let's say star, which means everything from users, okay? Realize that when you do a SQL command from the command line, you have to end it with a semicolon, and I hit enter, I'll see I get nothing back, okay? But I'm going to go in here and I'll say insert into users, okay? And you have to say where you're inserting to. So there's two parts of this. Inserting into the name field, the values, and I'll say I've got a user named Mo. And now if I say select star from users, I'll get Mo. And of course, even if I go and I quit, and I go back into this database, SQLite 3, Acme DB, SQLite, and I say select star from users, I'll see that I have Mo. Now, this is not a great database design because I really have no unique way of identifying the users in my table. As another example, there wouldn't be nothing that would prevent me that would say insert into users, name, values, Larry. Or I'll actually do Mo again just to show this. And now if I say select star from users, I'll see I've got two users named Mo and no way to identify the two of them. So there's another command that you could run, and I'm going to say drop table users. And I'm going to create this again, but this time I'm going to do something. A lot of database engines sort of come with this feature. Again, when we end up using some other tools, something called SqliteLite, which is going to be sitting on top of a database, we're not going to need to have to do this. But what I'm going to end up doing here is I'm going to create a table, users, okay? And I'm going to specify, well, I've got an ID, okay? I'm going to say that this is an integer. Not only is it an integer, but I want this to actually identify my user. So I'm going to give this what's called a primary key, okay? I don't want to have to define this primary key. So I'm also going to say auto increment, okay? This is going to now be a way for me to identify this user. And I'll say name again, text. And now I've recreated my table. And now if I go in here and I say insert into users, name, values, Mo. And I say insert into users, name, values, Larry. All right, let's do Mo again. And now let's maybe do Larry. And I go over here and I say select star from users. Now I know which user that I'm talking about. So that command will automatically end up giving you an ID, and then you could do things with the ID and say things like, and this is, by the way, the only thing that you're doing for this workshop is going to be reading data. You're not going to be inserting data or anything like that, so this is a little bit less of a concern here. But if I wanted to, I could say update users, set name equal to curly, where ID is equal to 2. Now if I say select star from users, I get Mo, Curly, and Larry. Okay? Nothing prevents me from creating another table here. So I could go over here and specify that I'm going to create a table, departments, again, ID, integer. You know how I was able to memorize this, actually? Yeah. By doing it a million times, and you really don't have to do it, and I am only doing it to show off for the workshop anyway. So primary key auto increment, looking it up is totally fine. And again, a department's going to have a name too, and this will be text. So now we've got our department. So for instance, we could do something like insert into departments. What fields? Well, we're going to go into name, what values, and let's say we have an engineering department. And let's also say we have a HR department. And if we go over here and we say, I think I just exited out of this by mistake. So let's do this again. I'll go SQLite 3, and this is going to be Acme. And now I could say select star from departments. Okay? So one thing you notice, unlike stuff that we've done before, is that this is being persisted, right? This is not something that's in memory. This is something that's persisted. It's persisted inside of the database, and we can access the database. Now, one thing that comes down to database design, there's really only two types of relationships that you have to understand. And those relations are when you have a relationship where one table belongs to another table, or one table has many entries. So let me give you an example of this. Let's say that we decided to, on our departments table, right now if we do schema, right, we'll see that our departments have a primary key for ID, and they have a name that's text. And by the way, I could write my SQL statements and add columns to them, but I'm not going to do that because I'll probably screw it up and go down a couple of pegs in your mind. So instead, I'm just going to tell you, just imagine that on the department table, you had a field for manager ID, okay? Meaning that for a department is going to have a manager, okay? And so the way that we would sort of think about that, again, and we'll make the distinction that not only does a department have a manager ID, but that manager ID is going to be an ID from the users table, okay? So the way that we think about that is that we say a department, right, is going to belong to, okay? A department is going to belong to a user, right? That user is specified by the manager ID. I mean, one way we could do that if we wanted to, I'll do this real quick and then we'll talk about another relation too. We could say drop table departments. And what I'm going to do here is I'm going to say create table departments. And I'll say we have an ID, which is an integer, which is a primary key. And we're going to auto increment it. And we'll give it a name of text. And we'll give it a manager ID, which is an integer. And we're also going to be sort of specific about that manager ID because we don't want to get bad data in our database. So we'll say it references the users table. Where does it reference the user table? At the ID. Okay? So what this is saying is that, hey, look, if you want to create a department, that's okay if you don't put a manager ID in. But if you put a manager ID in, it better belong to the users table. Okay? Once I end up doing that, put a semicolon here, I think. Okay? If I look at my schema, I should see this. Now, what that's going to allow me to do is, if I say select star from users, I've got 3 users, I've got no departments. So now if we go over here and we say insert into departments, okay? Let's make Larry a manager. So we'll say insert it to departments to the name and the manager ID. For values, we'll say the name of our department is engineering. And we'll say the manager ID is going to be Larry, and that's going to be 3. Okay? Now again, one reason we want to do that is that there's no reason that we want to put, there could be a lot of information about Larry. Okay? Larry might have an email address. Larry might have a date of birth. Larry might have a lot of other information. We don't want to store that in the departments table. Okay? We want to store the bare minimum that we need to store in the departments table to find out who the manager is. Okay? What we don't want to do is, if you could imagine, we don't want to have to update data in more than one spot. So if we end up going over here and I decide to now do a query and I say select star from departments, okay? I see engineering 3. Now what if I also wanted to find, hey, who is that manager? Okay, again, I could do this in 2 steps. Select star from users, where ID is equal to 3, right? But I could actually do this in one step, and the way that you could do that is by joining your tables together, okay? Sometimes the order doesn't matter here, but I'm going to specify what I want to get. So what I want to get is each department with the manager name. So what I'm going to do here is I'm going to say select departments dot name, and you can do this in one shot. I'll say from, you could break this up, from departments. Now I've just got engineering, okay? But I'll also say, not only am I going to do that, I'm also going to join this, okay, on users, okay? Join users on users.id. The ID of the user is equal to the department's manager ID. That's what the relationship is. The join is saying I'm joining these 2 tables and I'm specifying what they're being joined on. When I end up doing that, I'm going to get that same result, but just realize one of the things I could do here is I could go over here and I could say departments.name, and not only that, I could say, hey, look, we joined on users. Let me get the users.name, and I'll say as manager. So one of the things you could do with a SQL statement is that when you see that as symbol, you're aliasing. You're saying, hey, look, the data that I want is the user's name, but since you have a name in both columns, you don't want them to get mixed up together. And now if I do this, I'll see that Larry is the manager. By the way, notice how I don't see any of the other users, okay? Because they're not part of this relationship. If I was to go in here and say, insert into departments, and I was to go over here and I was to say name, manager ID, and I'll say values, and I'll say, well, we've got a HR department, and we'll let Curly be the manager here, okay? So now I'm putting another record here. Damn it. Okay. All right, let's run this command again. Let's see what happens, right? That's going to be Larry again. So now I've got Larry is the manager for 2 departments. Let me also just see what the ID is here, which we know. If I go over here and I say departments ID, so now I could see, so this is a little bit weird. User's name is manager. And I'm going to show you, this is not the way that you want to write your SQL. I'm going to show you a better way to do it. So this is going to be as manager, and this is going to be departments.id. So now I can see that for the department ID, I've got department 2. So let me modify this, and I'll say update departments set manager ID equal to Mo, Larry, and Curly, right? I did it in the wrong order. Okay. So I'm going to say manager ID is going to be, let's make it Mo, keep it simple. Manager ID is 1, where ID is going to be equal to 2. And if we end up running this again, we'll see we've got Mo and Larry are the managers of those 2 departments. So that relationship, by the way, works both ways. Think about it for a second. A department belongs, and you'll see we'll diagram this too. A department belongs to a user, okay? A user has many departments, okay? Because we could very well make it so that Larry is also, you saw it before, Larry could be the manager of the other department as well. And by the way, when we say a user has many departments, they could very well have no departments, okay? So we've got that relationship. And there's one more relationship we could have as well. But before we do that, let's quit out of this, and I'll show you a better way to run the SQL, and then I'm going to show you an even better way to run the SQL. So I'm going to quit this. And I'm going to go over here, and I'm going to say, I'm going to describe, I'll say Acme script SQL, and I'm going to create this file. And I'll go in here, and I'm just going to say select star from users. And I'll quit out of this. And instead of actually having to go in and type things on the command line, what I could do is I could run SQLite-3. I specify the database, Acme DB, SQLite. And I'm specifying, and again, you know, I remember that the arrow goes in this direction. I was on the car ride over here. I looked at this. Probably tomorrow I'll forget. But basically what I'm saying here is that I want to run this script on this database. And if I do that, it'll actually run it, and then I'll end up being done. And we can do multiple scripts here as well. So let's write a script. And what this script is going to do is not only create all the tables, but it's going to end up setting up a couple of relationships for us. And we're going to look at, again, we did a brief explanation of the belongs to and the has many. And we'll also take the case of, well, sort of the example of, well, what if a department had multiple managers? but we'll do it with a different relationship. We'll actually say, what if a user could belong to multiple departments? And we'll specify a role table where a user could have multiple roles in different departments. So in order to do that, I'm going to open this up again, and I'm going to write some SQL. So let's go here again, and this is going to be Acme script SQL. Okay? And what I'm going to do here is that I want to run this script, and I want this to work every time. I want it to drop my tables and recreate my tables. If you try to create a table and it already exists, you'll get an error. So I'm going to say drop. By the way, I'm going to get the syntax wrong for this, so let me actually look this up. SqliteLite, drop if table exists. And so this syntax is drop table if exists, and we'll say users. We'll have 3 tables. We'll say drop table if exists, departments, and we'll go over here and we'll say drop table if exists, roles. Okay? And then we'll create these 3 different tables. So this is not uncommon. What we're doing is, and very often in a test environment you do this, you wouldn't want to run this in your production environment with all your users, but in your development environment, in your testing environments, this is a pretty common thing to do.
You're using caps. Does it matter?
I see it both ways.
So there's no standard opinion?
I don't think so.
Okay.
I don't think so.
You're using plural names, aren't
Say it again?
they? Names for the tables are using pluralized?
Pluralized, yeah. I mean, you know, there's different philosophies on. I think what it ends up coming down to is if there's a strong opinion about where you are, where you're working, then go with them. But this is also pretty common. And what we're going to do over here is we'll create our tables and put some data in here. So we'll say create table users, and this is going to be an ID, integer, primary key, auto, increment. Again, we'll just have a name, which is text. Okay? And I'm going to cheat a little bit. I'll say departments. And the nice thing about this is that we could go over here. There's nothing that prevents you from making this nice and readable. And I'll set this up as a repo, so you could also use this as well. Again, it's going to look at the semicolon. It's going to know where this statement ends. And we'll put in one more thing here. And this is going to be the manager ID, which is an integer. And it references users. Where does it reference users? At the ID. So we've got this manager ID as well. If you wanted to just see if this would work, we could do that, but let's actually just put a couple of other things in here. We'll say insert into users, name, values is Mo. Okay, everything ends in a semicolon. We're going to do Larry, and we're going to do curly. So we've got our users table, we've got our departments table. And let's also just create 2 departments. We'll say insert into departments, and we'll specify the name and the manager ID, and we'll specify that the values are for the name, we'll say engineering, and we'll again give Larry the nod as being a manager. And just for the sake of argument, let's go over here and specify we also have an HR. So again, a department belongs to a manager, but a user can have multiple departments. Okay? If we end up doing that, we could just do a little check here and say select departments.name from departments, and we could also display the department's manager ID. Okay? So if I save that, what's that? Oh, thank you. Just want to see if you're paying attention. So if I do that and I kill this, and I run this command again, SQLite 3, Acme SQLite, Acme script SQL, I'll see that it ended up finding those users. Okay? So again, just sort of going back in this again. Let me rename this. This is bothering me. Move Acme script SQL to script SQL. A little nicer. Okay? Let me open this up. So one thing we could do here, just as an aside, right? I mentioned this before. So instead of just getting the department's name, let's also get the manager, and we'll say, now again, once we decide we need the manager, we're going to say users.name as manager, and we could say departments.name as department name, and you could break this up on multiple lines. It's perfectly legitimate. Again, this is why I want you to sort of get used to being able to do this rather than just using it on the console. But if we end up doing this, if we're getting something from our users, then what we can do here is we could end up doing our join on users, join users on users.id equals departments manager ID. Okay? Assuming that that gets us what we want, we could actually go down and look at another relationship. So another thing that we might want to do here is, let's say that we wanted to see all of the users and how many departments they end up managing. Okay? This gets to be a little bit tricky, but what we're going to be doing is we're going to be doing a join. Okay? And the way to sort of think about this is that we'll say select users.name, we'll say as manager from users. And one of the ways to sort of see this is to do your join over here. And we'll end up joining, and we'll join departments on departments manager ID equals users.id. Okay? So now we're doing this join, and what this would end up doing is sort of the same thing that we had before, but we'd end up getting two departments. Okay? So the way that I want you to think about this, if we just ran this, what we would end up getting is we would end up getting Larry, Larry. Okay? What we want to get is we want to get a result that says Larry, and Larry's the manager of two departments. Okay? So the way that I want you to think about this is that what you're doing is you're going to be grouping. You're going to be putting things in a bucket. And what's the bucket that you want to put it in? You want to do a group, and you want to group on users.name. Now, again, it turns out that Larry's the only manager. But let's say that Curly was also a manager. So you'd be putting all the Larry records in one bucket, all the Curly records in one bucket, and then what this gives you the ability to do is to aggregate those buckets. So you're basically saying, I want a bucket of all Larry's departments, I want a bucket of all Curly's departments, I want a bucket of all Mo's departments. Of course, Mo doesn't have any departments, so he's not going to show up here. Curly doesn't have any departments, so he's not going to show up here. But if we go over here, and I specify count star as count, you could call it whatever you want to call it, and I go and save this, and I run this command again, and I rename this. Didn't want to do that. Let's go back here. So this is going to be my SQLite, and this is just going to be script.sql. Incomplete count is count. Let's take a look. Select count as count from users. Thank you. Wouldn't have seen that so fast. Thank you. So now if we run that again, near user syntax, let's try this one more time. So we've got, let's make sure we're looking at the right thing. from users, join departments, group by, sorry. Group by, try that again, okay? So I see that Larry's got 2 departments, okay? Again, common relationship, a lot of times, what are other things that you could aggregate? Let's say that you have a list of orders in a database, okay? Let's say order items, okay? Each order item has a product ID and a quantity. So what you might want to do is for every single product, find out how many have been ordered. So what you would do is you would end up doing a count on this order items table. You would end up grouping it by the product ID. Again, think about where you want to set up the buckets. And this is what you're going to be doing in the workshop. This is what a good chunk of the workshop is. And then you would figure out what you want to aggregate. If you wanted to aggregate on something else, you could do a sum. A couple of different aggregations that you could do. Okay? Now, let me just do one other thing here, just so we sort of cover all of our bases. I want to create a third table. And let's do it up here. So I'm going to create a table called roles. And I'm going to specify, again, we've got an ID, which is an integer. It's the primary key. We auto increment. And I have a user ID, which is an integer, which references users from the ID table, of course. And I've got a department ID, which is also an integer, which references departments on the ID. All right? So we should be able to now create those roles table. Now let's just sort of think about what this gives us the ability to do. So now we could set it up so that, let's say, we want to put Curly into engineering and HR, and we want to put Larry into HR. Okay? So one of the things we could do here is I could go over here, and I'll say insert into roles. So we're going to specify that we've got our user ID and our department ID. We'll say for our values, and we're going to say that our department that we're looking at is going to be our engineering department. So we'll say, and we'll say that we're dealing with Curly here. So we'll say Curly, who's got an ID of 3, and the department has an ID of 2. If you want to, you could put a comment here. Add Curly to engineering, is that right? No, this is going to add Curly to HR. Okay. Let's also add Curly to engineering. And let's also go over here, and we're going to add Larry. Let's use Mo. We haven't used Mo. So we're going to end up adding Mo, and we'll end up putting Mo in engineering as well. So we should have 2 people in engineering, and we should have 1 in HR. Let's just make sure that that runs. Okay? We didn't run any query from it, but we don't see any errors here. So let's go over here and just run a script from here. So let's now look at our roles. Okay? What do we want to do with this? Let's get all the users and all their roles. So we could say select, and we'll say users.name as user, departments.name as department, from, and what we're going to do here, we know that we need to get our role. Okay? If you really wanted this to be clear, we could also specify that we've got a roles.id, and we could say we're going to end up getting this from roles. We're going to join roles users on users.id equals roles.user.id. Join departments on departments ID equals roles.department ID. Right, so what this should end up giving us is a list of the users and their department and what that role ID is, right? Again, when you end up having what this is, okay, and you'll see this in the workshop, what this is that this is a join table. The roles table is a join table. What it's doing is allowing you to have users that belong to many departments, okay, and departments that have many users, okay? This is not the manager situation. We could specify that that a department only has one manager, okay? But a user can belong to multiple departments. You could imagine that maybe in the roles table there's another key called primary, which might be what department is their primary department, maybe the date that they joined their department, maybe they have different titles in different departments. Again, kind of a silly example, but nevertheless, if we end up running this, we'll see that engineering is misspelled, either that or it's just cutting this off, which is possible too. But we've got Mo, who's in engineering, and then we've got Curly, which is in these other two departments as well. Let's just do one other thing here. And what we're going to specify here, let's just sort of think about this for a second. Let's say that we wanted to find out how many roles each employee has, okay? So we could look at these results and we could sort of figure this out, but let's actually figure out how many roles each employee has. So we're going to do, let's just put a comment here, list each employee's roles. And now what we're going to do is we'll say select, and what I need to know is I want to think about what you want your result to be. I want to get the name of each employee, and then I want to get the number of roles that they have. Okay? So I'm going to select users.name, and I'm going to get this from users. I'm going to join roles on roles.userID equals users ID. Okay? Now again, this will give me all the records, but I want to group all these users together. So I'll go over here and I'll say group by, and I'll group by the users.name. Once I end up doing that, this gives me the ability to specify an aggregate, which is to say I just want to count, okay? And I'll count and I'll call this number of departments, okay? So again, I'm taking the users, I'm combining them with the roles because I'm really interested in not just the users, but the roles. So I get all the matching records and I group them into buckets based on the employee ID, okay? And then I get a count of how many records are in each bucket. So let's run this. And if I end up doing this, I could run this and I can see Curly is in 2 departments and Mo is in 1.
So let's say we had the exact same script, but the only difference was we had an additional user that didn't have anything before to find the roles table.
He does. We do have that.
Does that user just get dropped by that?
It can get dropped. I mean, there are ways to deal with that, and you'll be doing that in the workshop. So there are ways to do different joins, okay, by specifying. So what we're doing now is when you do a join, you're saying, hey, look, I'm only interested if they're in both tables. And you'll see in the workshop, you'll end up doing what's called a left outer join. Usually it's a right outer join, and sometimes you could even call it outer join that says, hey, look, I want to get the match even if there aren't matches here. That's going to be a little bit more work to do with the count, but you will end up doing that in the workshop. For now, this is just sort of a simplistic version of it. Let me save this. So let's actually do this. I'm going to say git init. And I'll go over here. I'll say git.add. Let me actually do rm foo rm foo SQLite. And what do we end up using here? Let me just do this real quick. I don't want to get rid of my, well, it's not really that big a deal. But if I look at bi script.sql, actually do this. my commands here were always Acme SQLite. So I'm going to get rid of the Acme DB. And if I went over here, I could look at my status. Okay. Let me take a break here, and then what I want to do is I want to tie this together with Express. All right, so let me stop here.